The United States military published a standard. It requires a specific compound for long-term storage preservation. That compound absorbs 14 times its own weight in water. A 5-pound bag costs $3. You have never been told about it. The identical chemical sits inside a branded DampRid container. That container costs $20 to $30. An electric dehumidifier runs $200 to $400, and it dies the moment the grid goes down. The $3 version works in silence. It requires no power. It runs indefinitely. By the end of this video, you will know how to build a military-grade passive dehumidification system from a hardware store bucket and a bag of ice melt salt. And the reason you've never heard this from any official source is the first thing you need to understand. This channel exists for one purpose. We translate what institutions already know into what you can actually use. The military has research, agencies have data, corporations have formulations, and almost none of it reaches the people who need it most. That's what we fix. If that matters to you, subscribe. Not for me. For the next time we dig something like this out of a technical standard and hand it to you in plain language. This community doesn't run on fear. It runs on verified, actionable knowledge. That's why you're here. That's why we do this. Let's start with where this knowledge has been sitting. In plain sight, for decades. The document is called MIL-STD-2073. Its full title is Standard Practice for Military Packaging. It governs how the United States Department of Defense packages, preserves, and stores every category of material intended for long-term holding. Ammunition, medical supplies, weapon systems, optical equipment, communications gear, everything the military needs to function after months or years in storage. This is not a historical artifact. MIL-STD-2073 is a current active standard. It is enforced today, across every branch. And one of its core requirements for sealed storage environments is the inclusion of desiccant systems. The preferred chemistry for high-capacity moisture absorption in those systems is calcium chloride. The military did not invent this compound. Calcium chloride's hygroscopic properties have been understood in industrial chemistry since the 19th century. What the military did was validate it, test it, standardize it, and then deploy it at a scale most civilians never see. This extends beyond domestic depots. The container shipping industry uses industrial calcium chloride desiccant units to protect cargo during ocean transit. Temperature swings at sea create condensation cycles inside sealed metal containers. The industry calls it container rain. Calcium chloride units absorb that moisture before it destroys the goods. Billions of dollars in cargo are protected this way every year. So here is the tension, a compound validated by the Department of Defense, deployed across global shipping, understood in chemistry for over a century, and no official civilian preparedness resource has ever told the public to use it. Not FEMA, not the Red Cross, not a single mainstream readiness guide. So the military solved humidity in sealed environments decades ago. Now let's look at why humidity in your shelter isn't a comfort problem. It's a biological one. Before we go deeper, I want to mention something. The research behind this video goes further than what I can cover in 15 minutes. The vault is where the full operational library lives. Military field manual translations, material sourcing guides, shelter design specifications, ASHRAE data tables. Everything we reference here exists in expanded, organized form inside that resource. No filler, no fluff, just the compiled research. But everything you need to build this system is right here in this video. Stay with me. Now, here's what the science says about what happens inside a shelter without humidity control. The American Society of Heating, Refrigerating, and Air Conditioning Engineers publishes data on indoor environmental quality. So does the Centers for Disease Control. Both establish a critical threshold. Above 60% relative humidity, mold species begin active sporulation. The species that matter most in enclosed habitation are Stachybotrys cardarum, that's black mold, Aspergillus, and Penicillium. These are not nuisance organisms, they are respiratory hazards. Now consider what humans do inside a sealed space. A family of 4 produces 4 to 6 liters of water vapor every single day. Respiration, perspiration, cooking, just existing. In a sealed shelter with limited ventilation, ambient relative humidity pushes past 60% within days, not weeks, days. That is the sporulation threshold. That is when biological contamination begins. Calcium chloride changes the equation. Its absorption reaction is exothermic. It begins spontaneously when ambient humidity exceeds the compound's equilibrium point. Published equilibrium curves show that a sufficient charge of calcium chloride maintains enclosed space relative humidity below 40%. That is 20 full points below the mold sporulation threshold. Without this control, here is what happens inside your shelter. Soft goods saturate. Clothing, bedding, insulation, metal surfaces corrode. Condensation forms on every cold surface. Food stores degrade, medical supplies fail, and the air itself becomes a vector for biological contamination. The threat is real, the science is published, and the solution has been sitting in the ice melt aisle. Let's talk about why it stays there. 5 pounds of ice melt grade calcium chloride costs approximately $3. You can buy it at any hardware store. Any home improvement center. It is sold for sidewalk and driveway desing. A single DampRid container holds a smaller quantity of the same active ingredient, the same chemical, calcium chloride. That container costs $20 to $30. The math is simple. DampRid's business model is repackaging a commodity chemical at roughly 20 times the per pound cost. They add a plastic container, a brand name, and a shelf placement in the home goods aisle instead of the ice melt aisle. An electric dehumidifier costs $200 to $400. It requires continuous power to operate. It has mechanical components that fail, and in any grid-down scenario, it becomes a plastic box. Now here is where it gets pointed. FEMA publishes shelter guidelines. Those guidelines address ventilation. They do not provide a single word of guidance on passive humidity control for unpowered scenarios. Zero. Nothing. The military has a published standard requiring desiccant systems. A commodity chemical exists that costs $3, and the agency responsible for civilian emergency preparedness has never connected those two facts for the public. I want to be clear about what I'm saying and what I'm not. I'm not claiming a deliberate conspiracy to suppress this information. What I am saying is that the incentives align perfectly for this knowledge to stay buried. No manufacturer profits from telling you about bulk calcium chloride. The compound is an inorganic salt. It cannot be patented. It cannot be meaningfully branded in bulk form. There is no money in educating you. DampRid profits from the gap. Even just dehumidifier manufacturers profit from the gap. And FEMA has no institutional incentive to close it. Is that negligence? Is it something else? I'll let you decide. Now, whether that's negligence or something else, here's what matters. You don't need anyone's permission to use this. If this is the kind of content you came here for, hit subscribe. If you know someone building a shelter who hasn't thought about humidity, share this video. That's not promotion. That's spreading knowledge that could prevent a serious health threat. The vault link is in the description for those who want the deep archive. Before I show you exactly how to build this, here's what you need to know about what it won't do. Calcium chloride is classified as a mild irritant. Wear gloves when handling it. Keep it away from children. Avoid contact with your eyes. This is not a dangerous chemical, but it deserves basic respect. It does not kill existing mold. Let me say that again. It prevents the conditions for new mold growth. If you already have established colonies, those must be cleaned or removed separately. This is prevention, not remediation. It has a finite absorption capacity. The salt dissolves as it works. It must be replenished. A single unit may not be sufficient for a very large or very humid space. You may need multiple units. The brine it produces is corrosive to bare metal. Use plastic basins, glass, ceramic, not bare steel or aluminum. One more thing. Ice melt grade may contain trace additives. For extended enclosed habitation, food grade or high purity calcium chloride is preferable if you can source it. For shorter term use, ice melt grade works. Those are the real limits. Now here's exactly how to build the system. You need 4 things: a standard 5-gallon plastic bucket, a collection basin slightly larger than the bucket's footprint, a drill or punch tool, and optionally a piece of fiberglass window screen. Take the bucket, drill holes evenly across the entire bottom surface, 1/4 inch to 3/8 inch diameter. Space them roughly 1 inch apart. If you have window screen, cut a circle and lay it inside the bucket bottom before loading. This prevents smaller granules from falling through. Load 3 to 5 pounds of granular calcium chloride into the bucket. Use white pellets or flakes. Avoid any product with colored additives or mixed desing blends. You want calcium chloride only. Check the label. Place the bucket inside the collection basin. The basin catches the brine. Position the unit in your highest humidity area, corners, low points, in your sleeping quarters where human moisture output is highest. If your shelter has multiple compartments, place 1 unit per compartment. Elevate the bucket slightly if possible. Even a 1/2 inch of clearance improves airflow underneath and accelerates absorption. The system is completely passive, silent, continuous, no switches, no power, no maintenance beyond replenishment. Here's what you'll observe. The salt visibly shrinks over time. It absorbs moisture from the air and liquefies. Brine drips through the holes into the basin below. In a 4-person shelter, expect to empty the basin every 1 to 3 days. When the bucket contents have largely dissolved, replenish with fresh calcium chloride. Thus, a 5-pound charge lasts 1 to 3 weeks, depending on temperature, ventilation, and ambient humidity. For planning purposes, stockpile 25 to 50 pounds per anticipated month of shelter occupancy. Brine disposal is straightforward. Pour it into a latrine, a sealed waste container. or onto soil well away from plant roots and water sources. Never dispose of brine into drinking water sources. That's the entire system. A bucket, a basin, and a bag of salt. Let's put this together. A compound standardized by the United States military in an active specification. Validated by over a century of industrial and military use. Available at any hardware store in the country for $3. Capable of maintaining shelter humidity below the threshold where mold begins to grow, requiring no electricity, no specialized skill, no permission from anyone. This knowledge existed. It sat in military packaging standards, in ASHRAE data tables, in product safety data sheets. It was never translated for the public. It was never packaged for you. Now you have it. If you know someone who is building a shelter, planning for their family, and has never once considered what happens when 4 people breathe in a sealed space for a week, send them this video. This is not about growing a channel. This is about making sure that people around you have the same information the military has had for decades. Next week, we're going into the vault on another standard the military published and the public never saw. You don't want to miss it. Stay informed, stay prepared, and never wait for permission to protect your family.